Okay, so we have discussed about the different services of the operating system, right? So now we'll go for a view of the operating system services, where the operating services actually resides, right? First thing, let me tell you that user applications interact with the operating system. Operating system interacts with the hardware to get the work done. That we have discussed earlier. So look over here. The first part that you can see is the user or other system program. There are some programs over here. These are some user interfaces, GUI, batch, command line. These are some user interfaces, and this is the program that is executing. If an instruction is given through the user program, actually who is going to execute? The hardware is actually going, this is to be done by the hardware itself at the lowest level. So the lowest level is the hardware, and the user system programs will run over the in the first level or the top level. So what we are saying, this user program must interact with this operating system to get the work done. So is it understood? So this user program up to this interact with this operating system to get the work done through the hardware. Correct? So now we have, this is the first, this blue color that we can see. This is the user interface or user application that is running. And from this part what you can see with the blue second part is the operating system. Correct? So inside the operating system, what operating system does? It does it provides many services. We have discussed. There are many services which are being provided by the operating system. What are those? The program execution, the IO operations, file system, communication, resource allocation, accounting, protection, security, error detection. So all these are the services. All these are the services that are being provided. Now see over here. So user application get the help of these services, take help of these services, so that it will be carried out in the hardware. Is that clear? Any user application takes help of these services so that it can be executed in the hardware. How a particular process, how a particular program will take the help of these services? Are you getting me? My question is, how a particular program will invoke a particular service. I want to communicate to another computer. So I need a communication service over here. So application program will request for the communication service of the operating system. So it will invoke this communication service through a call, by invoking a procedure called the system calls. Is it understood? What is a system call? An application program wants to get or wants to have access to a particular service of the operating system. Any user application wants to have access to a service of the operating system. To have access to the of a service, it has to invoke some system calls, or in general, like our function calls. Here we say it is a system call. Is it understood? Every system call in return, invokes a small program. So suppose the program wants to invoke the communication service. It will give the code that I want to access this communication service. Then in return to that, a small code get executed. A small code get executed, right? And by using that code, it will avail the communication service of the operating system.
Sir?
Yes?
So the user interface will get the service through system call.
User interface will get the
service through intercall, means it will invoke the system call and get the service.
Yes, yes.
Then it will work in the hardware.
Yes, correct. So,
So system call is like a mediator between the user interface and the service.
correct, correct. User interface and services. If you want to avail a service, you have to invoke a corresponding system call. Correct. For example, if I want to copy a file to another file, that might be requiring 100 of system calls. Correct. I want to open the file, I want to close the file, I want to read content. So for everything, I have to invoke one system call. Because it is not a simple, it has to, many operations are required for all those different system calls. I will give an example also, but for the time, but now you remember user interface, to get any help of the service, it has to invoke a system call. So there are a lot of system calls are there. It has to select a particular system call and invoke. Is that understood, everyone, or anybody having doubt for this slide? Okay. So, coming to the system components. The first one is the process management. Process, I already give you a definition that the program is in the state of execution is called a process. When it is there on the disk, suppose I have written a program only, I have saved it, it is on the disk, it is a program. But when you try to execute, now it is called a process, because it is now in memory and is ready for execution. Once it is there in the memory and ready for execution, we said it is a process. So program is in the state of execution is called a process. When it is on the disk, we say it is a program on itself. So it is a unit of work in the system, which is a management of following types of processes. So there are actually two types of processes are there: operating system processes, user processes. What are those? If I suppose I will say I will invoke the MS Word, I will start MS Word. If I start MS Word, it is a user process. I want to write a C program and execute it, it is a user process. Correct? I want to invoke a particular application Winamp, it is a user process. But there are some processes which execute by the operating system itself. Suppose, for example, in Windows, there are various processes that are running at the background for optimization, for getting your input, for checking errors and corrections. So those things are some programs which are executed by the system itself. Those are called the operating system processes. Is it understood? If you want to check that what are the processes running in my system, you can go through your in Windows. If you go for Alt Control Delete, if you press, you will find a task manager. In task manager, it will show you that what are the processes running. Some of them are user processes, some of them are operating system processes. Correct? For example, let me show you that if I go for, when you go for Alt Control Delete, it takes you to the task manager. You will see that there are various processes that are whatever these apps are user processes. These are your user processes. These are your background processes. Correct? Can you see these background processes? There are various background processes are there. Antivirus programs, there are.
Sir, the PPT is only showing.
Okay, it's only showing the PPT. No? I'll do one thing then. I'll take a print screen. Okay, let me put a slide over here and I'll show you. Just I have taken a screenshot of my screen from the screen. Just see over here. When I press Alt Control Delete and I select that task manager, this is the screen that appears. So you can see over here, these are the different processes that are running. different processes. And besides that, there are many processes are also running in the system. These are background processes. These are system process. These are the system processes that are being executed. Is it understood? So here it says how much CPU is used, how much memory, network, those are being given over here. Is it understood? So it says that multiple So you have multiple processes, we have the multiple number of operating system processes are also executing in the system. So some user processes and some operating system processes may execute at the same time. Example of processes, your user program, compiler, word processing program, sending output to a program, all these are different processes. Sometimes a process needs initialization of data. Sometimes a process needs initialization of data. For example, you have written input some value, so that value has to be inputted, right? A process which shows a file on a screen needs to file name as initialization of the data, right? So in that case, what we do that those are interactive processes. A process needs certain resources like CPU time, memory, files, IO devices. When a process terminates, the operating system reclaims the resources. That means what? If a process, your program over, then whatever the resources the process was availing, those will be reclaimed or it will be added to the avail list. So it does what? It does the process management, correct? Then we have a program is a massive entity where a process is just an active entity. If you go for difference between program and a process, you will see that program is a passive entity, right? Because program is reside on the disk. Program reside on the disk. Process reside in the memory. This is another difference. I have not put a slide. I'll put a slide that difference between program and process. Program is a passive entity, whereas process is active entity. Program is there when it is there in the disk. It is program. When it is there in the memory, it is what? This is a process, right? And programs are static in nature and processes are dynamic in nature. These are basic differences. Anyway, it is same based with different name. That means the same one. The program is also called as a process, but at what we are saying, when the beast is sleeping, it is called program, and when it is executing, it is a process. Is it understood what is it? It is the same beast with different name. When the beast is sleeping, we say it is a program. That means when the code that you have written or code that you are using is not, you are not using, it is there on the disk, it is, we say it is a program. When it is executing, we say it is a process. Correct? A process can have multiple threads as well. The process can have multiple threads. We have a thread management, one topic is there on the thread management, but for the timing you remember, while you execute a process may have some some number of threads that may run. Threads are lightweight. These are like lightweight processes that they will start with few number of resources. For example, if you start a MS Word, for example, if I start a MS Word, you will find that you go on typing, you will find some, if you have a grammatical error or a, some spelling error, a red mark or a green mark that appears below the text. That means when the MS Word is running, MS Word is a process. When the MS Word is running, at the background itself, some threads are also running for checking the spelling and grammatical errors and all this. Correct? So, for example, in a notepad program, one thread will be taking user input, another thread will be printing the document. In MS Word, one program, your process is your MS Word, and the threads can be checking your grammatical error, checking for other errors or spelling errors. Correct? So, a process can have multiple threads, right? And each thread will have their own task and own path of execution in the process. See how beautiful that is being designed. It says that one process may have multiple number of threads, and you can have multiple number of processes as well. Suppose in Windows, multiple programs can run. Each program is one process. Each program is one process. A process can have multiple number of threads. A process can have multiple number of threads. Now it says all these processes run in isolation. They cannot interact. They do not. One cannot write into another memory area. They run in isolation. However, they can interact. Processes can run in isolation. Everyone is allotted with different memory space. Every process is given with different memory space. They will run in their own memory space. However, they can interact with each other. I can send message to process number 3. Process number 3 may send message to another process. So they may send message, but they do interact. They do execute independently. Now, suppose 5 processes are running, or that means 5 programs are running, right? Each process may have a number of threads. One process have 3 threads, another process have 2 threads, another program may have 10 threads. And each of these threads also, it says that these threads have also their own path of execution. Correct? So every thread also have their own path of execution inside the process itself. Correct? So even if you are running multiple number of threads or a huge number of threads also, the operating system takes care so that one thread will not write into other threads memory. So they will have their own path of execution. A single threaded process has one program counter which specifies location of next instruction to execute. So that means if you have a single thread process, so a process and that is only one thread, that means all our resources can be dedicated to that. So a single threaded process has one program counter, because one program counter which will go on executing each of the statements, which specifies location of the next instruction to execute. What is program counter? You have read in architecture. Program counter keeps track of next instruction to execute. So I am executing a program through operating system. Program counter keep track of next instruction to execute. So in a single threaded program, I need a program counter. But if it is a multi-threaded program, every thread is running independently. Every thread is running because we have said that every thread has their own path of execution. So in a multi-threaded process has multiple program counter, because as each are running independently, has its own path, then how will you keep track of which thread is running which instruction? So I will have multiple number of program counter. This we can say as a thread counter also. So one counter for the process. If you have multiple processes, then for every program the program counter is being set. If a process has multiple number of threads, then the threads can also be executed and that can be governed through another counter. Each program counter points to the next instruction of a particular thread. So this is the work of a program counter. So is it understood? The operating system is responsible for the following activities in connection with process management. It is responsible for following activities in connection to the process management. What it does? Creation and deletion of user and system process. Is there any time sharing? There is a query over here. That any time is there any time sharing to the processes running under various threads independently? Okay, like we have for different processes that are running, we have different scheduling algorithms for them. Similarly, for managing the threads, scheduling algorithm is also used. Like it may be time sharing for every thread will may be given with actually in general it is run randomly. They are being run, all these processes, all these threads run randomly. However, we can have control on the threads itself by implementing different algorithms, right? So we can also give a time set, so that time sharing also we can make it by forcibly writing the codes in that, correct? So the in multi-threaded system we can have a scheduling algorithm that what is the order in which it can be executed. But in general, the thread programs that you do, they can run in random. In lab also we'll do some thread programs. Okay, so now what you have, the creation and if you have remembered in your Java language, in your Java you have done the multi-threading programs, right? In multi-threading programs, what you do, you can create multiple threads, but user has to write the program to manage them, because they are being running in a random fashion. You do not know that which process is running at what time. So you have to write the for synchronization, correct? So similarly, you have to write the code for this creation of these processes or threads. The operating, what the operating system process management also does, the creation and deletion of user and system processes. So if whenever a program I want to execute, it will go to memory, a process has to be created, and after completion of the process, that has to be deleted. This should be taken care by the operating system. So operating system is responsible for creating the process, deletion of the process. Not only that, creation and deletion, this is also responsible for suspension and resumption of the process. So when a process executes, sometimes suppose there is a statement scanf some value, scanf %d and % of n. So it will wait for the user keystroke. Now user will take 10 minutes to input the value. It has stopped the execution, goes for some other work, and while he return back, and then he input the value. So the process has to be suspended temporarily, and when the user comes and wants to interact, the process should resume to its to its previous state, correct? So sometimes the process may need to suspend, and whenever required, it should start from that position from where it is being suspended. It should resume from which it has been suspended. So suspension, and so it is not a small task actually. Why it is there? Because when you suspend a process, what happens? It has a current state, some variables are being modified, some it might have taken some resources. When you suspend it, so those values you have to keep it somewhere. You have to keep the variables, you have to keep the program counter, what variables are being modified, which resources are taken, how much resources are taken. All these information has to be kept. Then only you can suspend a process. When you try to resume it, what it does, it reloads those informations. How many resources, what resources are being used, all these informations are reloaded so that it can start executing or resume from its last execution. So suspension and resumption is not easy task. Okay. So in process management, we can create process, we can delete a process, we can suspend and resume a process, and it also has the provision for process synchronization, process communication, and deadlock handling. What are these things? First thing is that process synchronization. This comes under this process management. We have a chapter dedicated for this process management itself, the process synchronization. Very important chapter. So, what is this process synchronization? It says that when multiple processes interact with each other, that means those are interacting processes and sharing some common data. Two processes sharing the same data. Two people have a common account. Then how two or multiple processes can, multiple transactions they will do. If you have two people have the same account, joint account, how the operation can be carried out? Because both of them may want to withdraw the amount at the same time. They have, suppose total 5,000 rupees they have in their account. Both will use, because as it is a joint account, they have been given the permission. The moment the person is taking out from the ATM, another person is taking out from the bank at the same, exactly at the same time. Then there is a problem. Then how will you synchronize it? So the problem occurs when two processes have access to a common data, right? So if it is a serial execution, one after another, processes are executing serially. One process is there in the memory, then we may not require that complexity of synchronization. There is no problem. If in a track, so in a running track, if one person is running, he will become fast and no, because all resources are available to him only. Problem occurs when you have multiple number of people are there, right? One may cross another another lane, or there might be some problem over there. So process synchronization required when multiple programs reside in the memory and they will be executing, and particularly when they are sharing some common data. When they are sharing some common data, correct? And the process communication. The process communication says that during the execution of the process, two things may happen. The process can run independently without communication. Independent processes, they do not communicate with each other, or the processes during their execution communicate with each other. They need some data to be passed, some information to be passed among themselves, right? So if two processes or multiple processes wants to communicate with each other, how they will communicate? How whether they will have a common location where both will write. If two processes has a common location, see, if one will write, other can see, or second one can write, the first one can see. If five people wants to communicate, they will have a common location. And if it is for a particular process, then it may write the process ID and it may write into the common location. Otherwise, what may happen, they may communicate by message passing, like we send mails or we can send letters. Similarly, one process will give a message to the another process for communication. Understood? One is shared memory through which they may communicate. Another is message passing through which they can also communicate. Correct? So process synchronization, process communication. Another is the deadlock handling. What do we mean deadlock over here? There might be a situation that a situation may occur in the system that none of the process could able to continue their execution. They will be in such a situation that none of the process could able to continue its execution. Correct? That situation is known as the deadlock. That situation is known as the deadlock. One topic, one chapter is being dedicated for this deadlock in our operating system paper. Correct? So if it is there, if a deadlock occurs, then how to handle the deadlock? Let me query over here. So if a deadlock occurs, then how to overcome from this deadlock? Okay, so before continuing, let me take the attendance first. Otherwise, I may forget and it will go out. Roll number 1, 2, 2 is a permanent. 2 is not there. So 3, 4, 5, 6, 7, 8. 22 is 22 roll number 20, 23, 24, 25, 23, 22, 23, 24, 25, 27, 30, 37, 39. Okay, let me call out the absent roll numbers again. 2, 22, 23, 24, 25, 27, 30, 37, 39 and 73. Roll number 14 present. Yes, 14 I have not called the absent roll number. 14 is present. Okay. Okay, if you have any query, you can ask me now. I have only discussed today, I have discussed only the process management, right? So there is a query from Chinmay that during a peripheral device installation, we install certain drivers. Yes. So does the driver define system call to the operating system for using the device hardware or is different? Okay. So see over here, device driver is a program or not? So whenever device driver wants to interact, device driver is a program actually. Device driver is not a hardware. So device driver wants to have some access to the hardware. That means it wants to have interact with some of the services of operating system. So therefore, it is also the device driver also makes a system call to avail some services. So whether it is a device driver, it may be any user program or a system program that requires a system call to avail any service of the operating system. Is that understood? Okay. Anyone else? Anybody having any doubt now? Any queries? Okay, then we'll end the meeting for today. So I'll end the meeting for today now. Okay.